Hello, everyone, and welcome to today's webinar for the digital twin for owners and operators approach and benefit. My name is Philip Rakic, and I'm one of the product managers here at the Experts, responsible for the browser-based viewing and co-responsible for IntelliPID. Today, we're going to have a look at the creation of a digital twin and the challenges that can appear on the way to a digital twin and how to utilize it as an owner operator. So let's have a look straight at the agenda. So how do we start actually creating a digital twin? First of all, we should start organizing the available information documentation. Create an overview of what have we got currently. Then identify the challenges that might stand in the way of creating the digital twin. Defining the approach to digitalization in UPV. So how do we actually start building up the digital twin? And what are the benefits for owners and operators in maintenance, operations, turnaround management, engineering, and EHS? So what are the challenges we can face with information and documentation available? First of all, often data structures are outdated or available only in analog format. 3D models can be out of date or do not exist at all. As you'd say, it's historically grown. Information is stored in different sources, folders, programs, and not really available in one central point. Information is stored with the different indices. That means that an application A, they might be stored by their index in that software, and on a different application, it might be stored with a name or a technical place or infrastructure name. So identifying which documents, which information actually belongs together to get it on a common ground. And different departments work with different management systems. So, for example, maintenance might use a totally different software than operations or EHS. So, getting centralized information could be difficult here. So, what is the approach to digitalization of existing data? First of all, you should start by digitalizing existing documentation, drawings, and PNIDs that are not available in a digital format yet. This means scan available non-digital documents like drawings, PNIDs, etc. into PDF. Next step, you can actually use simple PDF editing tools like Adobe Acrobat, PDF Exchange, Phantom PDF, or similar to add textual tags in form of PDF comments to make actual readable, machine readable comments in your documentation. Then you could use the document adapter or the PDF PID adapter for integration of exactly these documents into your UPV model. You can aggregate available information and lists with additional data like line lists, valve lists, equipment lists, etc., and so on. So what would be the approach to 3D model data? You could check which 3D models are available in your company. Check if the information is up to date or if these models are already outdated. And if no 3D model information is not available at all, there's several options here. For example, remodeling existing plants. So anyone who might have tried this will have found out remodeling an existing plant is a really time-consuming task, and it proves to be very, very long-term and in the end also very expensive. Instead, point clouds are created quickly. But the problem with point clouds is, as the name says, it's just a collection of millions of points, but no objects as such, and no way to actually attach documents or additional information to a point cloud. So with the UPV meshing and laser scan clipping technology, point clouds are first of all converted to smart models quickly and efficiently. What does smart models mean? We're creating a wireframe mesh, a textured wireframe mesh from the laser scan, and we can use laser scan clipping and our laser scan spraying clipping technology to single objects off the laser scan and make them objects of their own with attributes and the possibility to attach documents to them. Bringing different sources together, that's actually the final step of creating a digital twin, and following the previous steps creates a base for full data integration. This means, for example, intelligent laser scan meshes can be enriched with the data coming from those aggregated lists. Documents can be mapped to individual objects in the model. Tagged PNIDs can be interlinked with a 3D representation, meaning you can jump back and forth between your now intelligent PIDs, IntelliPIDs, and single objects in your 3D model or laser scan. This way, all available data can be connected in one single point of truth. By bringing together all available information, a decent base for building a digital twin is created and can be used to further extend the functionality of your digital twin. So, after base has been created for the single point of truth, further systems can be connected to UniversalPlantViewer digital twin. For example, you can create an SAP connection showing live information coming from your SAP database. You can connect to your document management system, linking to documents that you manage in your DMS. You can use, for example, software like Shift Connector that actually helps you manage the shifts, your production um, over the shifts and shift turnovers, but also failure reports and management, and so many more. Plant Viewer is the ideal integration platform for all of this, thus rounding up the integration and enabling all departments to use one common base for the information as their single point of truth in the day-to-day business. So what benefits can we actually take from this? For example, in training, employees can be trained based on a 3D model. So even before setting a foot into the plant, they can already be trained. Safety trainings can be conducted virtually in a digital twin. Again, before entering the plant, you can train the location of escapeways, emergency showers, etc. These can be visualized, and you can also conduct some safety simulations to simulate emergencies and train your staff beforehand without taking the risk of going into the plant with untrained staff. Maintenance. So you can plan your maintenance visually. This means you can check space requirements for a maintenance task. You can have a look into the maintenance history. Again, you can also simulate the tasks with animations, visualizing completely step by step of the maintenance procedure, and see, okay, how long will we need for this? can we actually do it this way, or are we lacking the space and similar? So what further use cases do we have for an owner and operator? One of the major, well, I'd say challenges is LOTO procedures, meaning lockout, tagout procedures to define lockout, tagout lists, to define a state for a certain valve before shutting down a branch to exchange a pump or similar. You can prepare turnarounds and revamps. Especially in turnarounds, time is also a very important cost factor. During a turnaround, you really want everything to go by schedule. And with UPV, you can prepare that by preparing reserved spaces for scaffoldings, for cranes, checking if the motion radius of the crane is sufficient in the place where you plan to use it. You can also create reserved or blocked security zones to ensure security and prevent some risk of accidents. You can initiate fault reports from your digital twin going into your data management system, being SAP, Shift Connector, whichever one you're using, to actually create a fault report out of the 3D model. You can integrate live data coming from sensors. You can colorize objects in your 3D model, in your laser scan, on the source of real life sensor input, and many, many more, depending on your individual requirements. So if you have any questions, by the way, feel free to ask them through the questions panel here in the webinar. And after the live demo, we will have a Q&A round. So we'll have a look at this together. So these are some prerequisites and some approaches to creating a digital twin. But I think the most benefit we get actually when we look into a live demo, what are the options and how do we do this? So I picked an example where we did not have a 3D model at all, but instead used a laser scan of a building and according pictures to complete the picture. Excuse the pun. So basically, what do we do here? We had this laser scan of an object of a building, and use this actually to overlay pictures of the building itself. For example, here, the northern face. And by using the picture overlay, recreate the look of the building to have a real digital twin here. So not enhancing this by using some type of authoring tool, but instead we used onboard sketching features of UPV to complete the digital twin in the real 3D model. So when I use the slider, I'm actually sliding between the model and the picture, and you see how close we get with only, I think it was only 2 days that we needed to create an object like this. So what other benefits do we get from digital twin for an owner and operator? First of all, there's maintenance relevant information we get out of this. For example, when I click on this equipment here and go to attributes, I can straight away find the maintenance and operation manual for this equipment here. So when I open this, you see it's an embedded document that's actually showing me the full manual and full maintenance information I need to get to this machine. So no need to look for the information in any type of document management system. It's right at the tip of your finger, just by clicking on the object in the laser scan. But for some advanced features, let's actually go to a pre-saved view I've created here in the pressure sustainment room. I mentioned creating individual objects from a laser scan. So this is what happened here, while the equipment I just showed you before is actually modeled by a bounding box around it. Here we went a step further, marking an equipment and creating a totally separate object here. When it comes to interconnecting with PNIDs, well, a long time on the market, you could either have just simple PDFs attached to an object, or you would have some smart PNIDs coming like from intergraphs or hexagons, smart plant PNID, where you could link intelligently, but beyond that, there were no options. Instead, you can use now our PDF PID adapter, where it recognizes the tags of objects, and we're able to connect directly to the name tag of the object in the PNID. And this is a PNID coming from a PDF file. So what else can we do with it? I can also here click on the tag and jump directly to the pipeline, having the pipeline highlighted in full, and even being able to turn single objects on and off within the laser scan here. I can, for example, colorize objects for defining their open or closed state. So let's say I would want this opened and this bypass between the two pipelines closed. So I could set up a visual information and a visual instruction how to actually lock these down. We can add additional information that's not part of the initial authoring system, and a laser scan not coming from an authoring system does not have any type of information attached to it, and still we have information to the single valves, possible limit switched, bidirectional flow, no material corrosion requirement, and similar. So we can add a whole workload of information to basically initially jam graphics. So, but talking about lockout, tagout, what other options do we have? Let me switch to demo plant that you might have seen before. I could go ahead and add attributes to actually define the lock status of an object. Say, okay, this is a control valve. I'll leave it at unknown. So for this one, I can set lock status as locked open. This one, this valve here, to locked open. And have these small valves here closed, unlocked. Being able to also store this information in some files or visualize them by their lock status. So by double clicking here or actually opening our custom attributes panel to have the color legend and color key displayed in the system. Beyond that, let me go back to the normal view. Beyond that, we're also able to do animations to actually do a simulation of removing a pump, for example. So in this case, you see I've marked up a pump here, which is a part of the laser scan, and still made an individual object here. So when I start the animation, you can see me simulating now taking the pump from its initial location. So basically moving a part of the laser scan within the laser scan, leaving the rest of the laser scan unscathed, and now putting a new pump in to just see, okay, does it fit in here? What else could we do? Let me just close this animation here. And okay, go to different view. I haven't actually saved the view, obviously. And let's say in this view, we want to exchange this control valve in the middle and replace it by a new one. How would we approach that with a lockout tagout procedure? So first of all, we would shut down this valve here, turning red, then the actually downstream one, open up the small relief valves here and exchange the control valve in the middle, displayed in blue here. And after building this valve back in, shutting closed the small drain valves here, and then going backwards, opening the valve downstream and opening the valve upstream of the control valve. So this is, again, just one of the examples how to utilize UPV and UPV's functionality in a day-to-day business. For turnarounds, for example, we could also do an animation of a crane and a crane removing a vessel from the plant to check space requirements are similar as I mentioned before. So let me do this animation in double speed. So positioning the crane, checking do we have any collisions, do we have any issues with approaching the vessel that we want to remove, and do we have any other objects in the motion path of a vessel we're moving on the way to actually place it on the reserved space for a closer checkup during a turnaround. So again, one of the options that a digital twin gives you, additional to having, to just summarize it, having all documents, all information, all attributes centralized in one space, connecting to all your department single systems. And knowing that every company has its own procedures and its own infrastructure, I don't think there's a one fits all recipe for creating a digital twin, but we're more than glad to help analyze your data and see what the best approach would be for you to get to a digital twin. Creating a digital twin is not a moment in time, it's a process, but starting step by step, you can build up your digital twin in a very short time at very low costs.